Demineralized bone matrix, or DBM. Our next category now is actually a subset of allograft bone known as demineralized bone matrix, or DBM. I think a discussion of DBM is really best done by first talking about and understanding how DBMs are manufactured, because I think that gives us a lot of insight into their potential mechanism of action and their usefulness when brought into clinical practice. In this slide that I borrowed from University College of London demonstrates very clearly how DBMs are manufactured. The manufacturers start with human cortical allograft bone, and it's then digested in either hydrochloric or nitric acid. As shown in this slide, these investigators took a piece of cortical bone and suspended it halfway into a beaker full of hydrochloric acid. What you see happens here is the acid dissolves all of the mineral component, the calcium phosphate in the bone, which is the portion that would render that bone osteoconductive and allow bone to grow onto it. What's remaining is a mixture of proteins that is between 95 and 98% collagen type 1. Among the remaining non-collagenous proteins include such things as the BMPs, or bone morphogenetic proteins. So in theory, those trace amounts of bone morphogenetic proteins have the potential to render this material osteoinductive. In fact, most of these materials, when they are tested prior to being brought into commercial use, are placed into an athymic rat model, either in a muscle pouch or subcutaneously, and the demonstration of bone being formed in that model is the basis for the marketing of most of these materials. Bay and his collaborators published a pretty interesting study in which they measured directly the amount of BMP2 in a wide number of commercially available DBM products. They measured this by use of an ELISA assay, and the results are summarized in this chart. A couple of interesting things can be found. First, looking from top to bottom, brand to brand, you can see a fairly wide variability in the amount of BMP in these products. As interesting, or perhaps more interesting, they took this a step further and actually opened 3 separate boxes, 3 lots, presumably 3 different donors in each brand. And looking left to right, you can actually see more variability from box to box than there was in brand to brand. In my mind, possibly the most interesting finding from this study is if you look at the units. The amounts of BMP they measured in each of these products was on the order of picograms per milligram, or on the order of 1/1000th of the concentration that is bioavailable in normal physiologic bone healing. Now, this study was then followed up by this study done by Jeff Wong and his collaborators. They did a rat posterolateral spinal fusion model using a number of the most commercially successful DBMs at the time. And interestingly, they found with one of these products, 0 of the animals achieved a successful posterolateral fusion, while at the time, not only was that one of the DBMs shown to have roughly median concentration of BMP as the others, it was in fact one of the most commercially successful products at the time. Subsequent to that, that company went on and effectively failed and went through Chapter 11. That technology was acquired by another company, it was rebranded, and that exact same product is now once again a commercially successful DBM in the United States. So enough about animal studies. I think most importantly is the human clinical experience, and particularly what's been published in the literature. Now, DBMs have been commercially available in the United States for over 2 decades now, so most folks assume that there should be a large number of peer-reviewed published clinical trials. In fact, that turns out to not actually be the case. While there are a number of published clinical studies, to the best of my knowledge, only one of those is a level 1 randomized trial. In that trial, the conclusions were that the DBM was found to be useful in posterolateral spinal fusion. I think it's important, though, to understand, and if you read the materials and methods in that study, it was in fact a prospective randomized trial conducted at multiple clinical centers. Unfortunately, the control group, which was autographed, was an appropriate control, but the test arm was autographed with the addition of the DBM. And again, if you read more carefully into the materials and methods, you will find that the average patient in the control group received 20 cc's of autograft. The patients in the test group received, on average, 20 cc's of autograft plus the addition of the DBM. So while this has been reported as a prospective level 1 study demonstrating the efficacy of DBM, I think if you understand how this study was conducted, it actually doesn't show that at all. It perhaps merely only shows that the DBM did not degrade the performance of autograft that was already being used. To date, unfortunately, that is the best clinical study available to support the use of DBMs in spinal fusion. And furthermore, while these materials are marketed with the purpose of being osteoinductive and demonstrated to be so in athymic rats, to date there has been no published evidence demonstrating these materials to be osteoinductive in a human being.